hear me in Southampton.
Yep.
Hopefully everyone in Sheffield can hear.
Yep, all good.
Good stuff. So I will try not to bore you too much. Hopefully the volume's okay. I've learned how to use a clicker, so I think I've progressed. So as Joan said, I'm Mark Howes. I'm a senior asset engineer for drainage on Network Rail's Western Route. Been doing this in common with all the other speakers. I'll give a little introduction. So 15 years doing this now in the rail industry, mostly Network Rail. Incorporated engineer with the PWI, so very proud of that, and would encourage anyone in the audience to do the same. Registration is really, really essential. What I'm going to talk to you today about is drainage as a system through the lens of something that was pretty unfortunate. So I make no apologies. It's quite a hard-hitting subject. We've seen colleagues earlier talk about Stonehaven, Carmont, the terms are used interchangeably, but it's really important to me in terms of when the tracker works. Good. I got to do something with that. Arrow key. Technical difficulties. We're stuck on the first line. Thank you. Right, so 12th of August 2020, I was at work thinking, great, another day. Unfortunately, we had an incident. Not my route, it was in Scotland, Carmont, between Edinburgh and Aberdeen. Unfortunately, 3 people lost their lives. So we can all sit here and say, well, you could have done something differently. I'm going to stand here and say that we needed to do something differently on that day. We owe it to these 3 individuals. It's been something that's been close to my heart for a long time. Drainage asset management of the system. We talk about systems as engineers quite often, but we really do need to stop and just reflect that actually, is it important to manage drainage as a system? Absolutely, it is. When we get it wrong, things happen, people die. So a career in rail is really, really something that I'm passionate and want to share with you all, that actually having the ability to stop these things happening should be enough. It was enough for me. It's one of the reasons I joined, to stop bad things happening. We are the people that put in place mitigation measures. We stop bad things happening. So the accident, unfortunately, train 1 Tango 08, which was a HST travelling between Edinburgh and Aberdeen, hit a pile of debris. Now, I'm not going to go into this because we are running slightly shorter on time, but the crux of it is 3 people lost their lives. The train derailed on material that had washed out from a drain. So an area of the asset that's close to my heart. Drainage is responsible, and it doesn't, I'm not proud of it, and it makes me awkward every time I think about it and talk about it. And it should remind us that it is really, really important that we manage the drainage asset properly. We inspect it, we maintain it, we renew it. So this is the power car, the rear power car. You can see what happened there. We had a couple of pictures earlier in the ORR presentation. That's the train in several bits. Now, it derailed on something that was relatively small. So you think, okay, we got the track there, we got the 2 rails, couldn't have caused that much damage. You notice in there that we've got ballast on the right-hand side, which is the coarse granite material that holds the track together and provides the support. And we've got smaller stone in the middle, in the forefoot, the middle of the track as we call it. That is all of the shingle, that's the P shingle, the P gravel, that's come from the drain. That was at the top of the cutting. So the whole accident, the whole loss of life, the whole problem here is shingle that washed out from a drain. That is something that I'm not proud of, but it's something that we must talk about and we must share. And if it encourages you to go into a career in railway engineering, drainage systems, drainage asset management, doing all of those things right, doing the things that we heard about at Lewisham, correct maintenance of the geometry, correct inspection regimes, having things in a register, they stop these kinds of things happening. So really, really important. That is what the scene looked like when the RAIB turned up on site. This was about an hour after they had the report through a default, the problem, the derailment. You can see there just how much material has come down from the top of the cutting slope. The driver wouldn't have stood a chance. They would have come around that corner and they would have hit that debris. So it is really, really important that we think about the whole system. I'm just going to go through a couple of the key engineering details because we're a room of engineers, hopefully. Same in Sheffield. We had a drain that was installed by Carillion, no longer with us, but a drainage system had been installed by Carillion in 2011. That had been installed not in accordance with the design. So we often think about designs, and we had AECOM, we've got Atkins in the room, we've got consultancy firms that do proper verification. They look at levels, they look at the elevations, they look at all sorts of things that help us manage the railway system safely. This drain, for reasons that are now known, hasn't been installed correctly. So we ended up with material on the track. We had a very steep section at the top, sorry, the slope, and that ended up with material that was down on the track. So designs are great, but we've got to then take that ethos of looking at the system, understanding all of the various elements and parts of that into the construction. So if anybody gets involved in construction, the next slide is really, really quite hard hitting. That is what they found at the interface between the top of the drainage system and the slope where it went down to track. Now you think that's been under granite, ballast, that's been under shingle, that's been in the slope. No one will see it, right? It's buried, yeah? No problem. That's now in the RAIB report. That's been seen by HSE, ORR, just about everyone in this room, everyone in Sheffield. If stuff changes on site, we've got to make a point of recording it. Change is inevitable in life. Today, this event, we've had to move the speakers order around a little bit. Things change. That's okay as long as we communicate the change. So if I could implore everyone in this room and in Sheffield to make sure that in your careers, whatever happens, whatever designs you get involved with, whatever construction work you do, whatever assurance you do, make a record of it. And if it changes, it's okay. We just got to record it. That's a little bit of the geography of the site and topography, sorry. So you can see there, dotted white line at the top, that's the gently sloping bit. We've got the drain down to the track, and then we've got where the train, unfortunately, came to its final resting position. So it's really, really quite sobering. But all of these things that I've taught through in the last couple of minutes, we can think about in terms of those are things that you can take forward into your careers if you choose rail, and I'd employ you to do that. These are things that we can take forward and we can make a difference. We can change things. We can stop these things happening. RAIB, we've heard RAIB mentioned. If anybody wants a bit of CPD, anybody wants to look at anything in terms of learning from things that have happened in the past, and that's what I employ you to do. Rail Accident Investigation Bureau reports, branch reports, are a really good thing to do. It struck debris. That's the outcome of this investigation. It struck debris. So we installed the drainage system incorrectly. Network Rail wasn't inspecting all of that drainage system. So really, 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 I'm going to focus on one area that's so close to my heart, and I talk about it all the time, the system. So we talk about drainage. Yeah, I've talked about drainage for a few minutes now. We've had some track engineers in the room. That's great. We fail sometimes as an industry to think about the system. So what we've really got to focus on, and it's why I'm here, it's one of the reasons I talk often about this, and it's why I'm a member as well. This is the big picture. There's workshops been done on this, but we've got to think about the system. So if you're a track engineer, your interventions could have a huge impact on the earthwork. Vice versa, if you're an earthworks engineer, your interventions could have a huge impact on the drain, on the track. So we really got to think about the systems interface. When we do that, I think we're on to a winner. So Systems are really important to me. Just wanted to share with you a few pictures from what we do, kind of typical day in the life. I think Brian was asked earlier, what does a typical day look like? This is perhaps my version of a typical day. That picture on the right is a drain. Believe it or not, that's full of ballast. It's collapsed. We had to find it. We've got these lovely new machines that make stuff a lot easier. So we did do an awful lot. Even 10 years ago, we were doing a lot by hand. We're now doing much more in terms of mechanization, which helps. It helps manual handling, sufficiency as well. The ORR, you heard them say earlier, less money, less time, less access. These kinds of pieces of machinery can really make a huge difference to what we do. And renewals, of course, we have an aging infrastructure. We have to renew things. So this is just a couple of examples of where we put new drainage in. Kind of gives you some idea of the cost there, just to give you a broad brush. 708k for one of these jobs. So we're spending that money that the ORR agrees with us in the determination wisely. It is a challenge on occasion. We have limited access. We have old infrastructure. We've got designs to do. These were designed by Aircon, by the way, just a plug there. And I think the last thing that really, really gets me, and it's where I started, I should have said at the start, I've been in this role for 12 years. 3 years prior to that, I've been doing drainage inspection, drainage maintenance, track maintenance. So maintenance is absolutely the first and last line of defense. And we forget the importance of inspection, the importance of maintenance at our peril. So there are track engineers in the room here. There are people in Sheffield, I'm sure, who are involved in maintenance in some way, shape or form. Spending some time in maintenance at some point in your careers, whether that be railway, whether that be somewhere else, it's worth it. It's a real eye-opener. You get very limited chances to do stuff, but you can get stuck in. So that was just a little run through of Carmont, a reminder of why it's important to manage drainage as a system, and a little bit of some of my background. So happy to take any questions. There's a couple of videos on the back of there.
Thank you very much, Mark. Thank you. So I don't know if we've got any questions here. First of all, Stephen, please, from Sheffield. No questions here. So I don't know if we've got any questions in the room.
I think we've lost everyone. Have a question from Greg?
Sorry, in CP7.
Yep.
Has the budget gone up for drainage renewals and improvements and maintenance?
It has, yeah. So substantially. So the focus from the business, from the ORR, from others has been that actually we've forgotten this thing called drainage. So we are about 30% more in CP7 than we were in CP6. So it's never enough. We need more. But the biggest thing that we've seen is a change of tact from reactive to proactive. It's not everywhere. It's not possible. We're not funded to do proactive interventions at every site, but there are more and more sites where we're proactively intervening. Money in terms of renewal spend has gone up. So that's positive. I see that as a huge positive, and it's one of the reasons I've hung around. It's one of the reasons I'm staying. I want to see this through. I want to see the journey. So it's a great place to work. There's a lot of money in drainage. So yes, it has, Graham.
Hi, Mark. Question here for you.
Yep.
The asset management system slide that you had in your presentation,
Yep.
That looked really, really interesting. And I'm quite interested in asset management as a student engineer myself.
Mm-hmm.
Could you talk a little bit more about what the process is when it comes to managing assets as a system, and how maybe they could have done that a lot better at Carmont, for example, to avoid that kind of thing happening?
Absolutely, that is a great question. So I won't go back to the slide, but the asset management system that I put on that slide is from the Institution of Asset Management. I think the most important thing that we all forget, whether it's signalling, whether it's track, whether it's drainage, is the asset register. So the only way in which professionally registered engineers, managers, maintenance leaders, inspectors can make effective decisions about when to leave something, when to intervene, when to defer, when to accelerate, You can only do that through the provision of an accurate asset register. So probably even before you get to the whole, how do you manage the asset as a system, the most critical thing for me, and it's what I've spent the last 10 plus years doing and kind of leading every day, is let's have a proper asset register which tells you everything about the asset base that you're managing. And then you can start to talk in a common currency between track, signaling, and actually there are trade-offs to be had. We've done something very similar yesterday. We've got a drainage renewal at Wantage Road on the Great Western Main Line. There's a track renewal, and the track renewal is going to have to go first because there isn't sufficient time to do the drainage. We've got great register details, so we know where the drainage is, we know what condition it's in, we know when it was installed. Same for the track, they know when it was installed. It was 92 by Balfour Beatty or Progress Rail at the time. So we've made some trade-offs, and actually by demonstrating that we've got good asset knowledge, we've been able to say we can wait a couple of years, but it's asset data. That is so fundamental to the way in which we manage the railway system effectively. So I could go on all day. Speak to me afterwards.
Thank you. Thank you, Mark. Oh, right. One question coming from here. Yep.
Yeah.
Okay.
Do you explain the acronyms in your title? So in your post-nominals, what they mean and sort of how you
get them.
Your career.
Do you understand that? Did you hear that, Mark?
I did. Yep, I've got that. So very proud. So the first one is a Bachelor of Engineering with first class honours from Sheffield, Hallam. So that's my railway engineering degree. So I'm an alumni of Sheffield, Hallam. That was good. Back there on the course as well. The Incorporated Engineer is with the PWI. So that is a great thing to have, working towards chartership, Brian. And then the others are member of the Permanent Way Institution, which I'm very proud to be, and then member of the Institute of Asset Management. So those are the things that are close to my heart. I wear them proudly. I put them up proudly. It took a long time to get there. I wasn't necessarily doing this at the start of my career. I didn't realise the importance of it. So I was definitely given a shove at some point, probably about 9 years ago now, to get on with it, Mark, by my boss at the time. So yeah, professional registration, the journey, recording of CPD, all those things is critical. It's the way in which to get recognised in the industry and to basically have some level of credibility. So hopefully that answers the question. And then that's a job site at the end.
Yeah. Thank you very much, Mark. Thank you. Can I just add one more thing onto that? I think
We got one question in the room, Joan, sorry.
okay. Can I just finish off saying something
Go
there
on.
first? Plus, I think, you know, what Mark's describing there about his journey and his career and how he collected up all of these letters. You are all young people sitting here at university studying. And once you get past this stage, then you're going to get a job. And you might think, oh, I've done loads of stuff at university. I know everything now. That's the end of it. I'll just go and do the job. But you will be continuing to learn for the rest of your life. So I'm 60. I'm still learning new things every single day, and I am required to do my job. You must keep on top of technology, new things that are going on. And when you are lucky enough to achieve accreditation through a professional engineering institution and you get titles like iEng or CEng, you have a responsibility to keep going with that all through your career, and you've got to keep learning all the time. So you can never think, hooray, I'm going to get to the end of this degree, I'm going to get the degree and that's the end of it, and I don't have to worry about learning new things again, because as well, I'm sure you all appreciate, life doesn't really work like that. Sorry, Mark, I just bit on my soapbox there.
No need to apologise. I agree wholeheartedly. We've got one
Sorry.
final question, I think, and then we'll probably have to
Yes.
move on.
Okay.
Just very briefly, does your drainage department collaborate closely with geotechnical and line side assets teams, for example, who work with trees and devegetation?
Yeah, absolutely. So we sit in the same office. We regularly speak with both not just earthworks and drainage or off-track colleagues, but also track colleagues, signalling colleagues, because the railway is so interlaced in terms of its systems that you almost can't do something without touching someone else's asset. We've got a drainage renewal at Newbury next week. We're doing 60 metres of pipe renewal in the 6 foot. The signalling asset put a foundations through the drain. That's the driver for the renewal. So that clearly that's an example where it didn't work, but to get through the design process and to look at the foundation details, yeah, so it's almost daily, and it just becomes a norm. So yeah, definitely.
Okay, so I think we'll draw this presentation to a close now. Thank you very much indeed, Mark. Thank you.
Thank you.
So our penultimate presentation now, we've got two speakers from a completely different discipline. Some of it is related to civil engineering, but most of it is about electrification. So we've got Simon Skinner, who is the engineering director for SPL Power Lines, and Lucy Clark, who is a recent graduate with a few years experience now of work since graduation. And they are mostly going to be talking about their experiences on Midland Main Line. Okay, thank you, Simon.
Joan. Yeah, hi. The slide's just coming up. So to introduce myself, thank you, Joan. I'm Simon Skinner. I'm engineering director for SPL. I've been with SPL for 7 years. I've been working in the railway industry for about 25 years. I am that old. I've pretty much just in electrification. So I started off in a design organisation, then got bored and moved into construction, then went back to design, then went back to construction. I've ended up delivering multiple projects in my career. The current project that we've just delivered is about 200 million. My first senior role in an engineering lead was which is called a CEM, Contractors Engineering Manager. I entered into service about 320 million pounds worth of electrification, and that's a complete rail systems project. So that's right. Anyway, he's got the slides up. So that's me. So I'm a chartered engineer. Sorry, could go on. I'm a chartered engineer through the IET. I'm also a fellow of the PWI and a fellow of the IET. And Lucy's going to introduce herself later when she gets to her slides. So Midland Main Line is electrification. Midland Main Line is an enhancement piece of work, and it's electrified between London and Bedford. We've extended the electrification system from Bedford through to Kettering, through to Corby. That's about 200 single track kilometres worth of electrification. The green bit on the screen between Kettering and Wigston is about 70 kilometres worth of electrification. We've just switched that on, just entered that into service. That was a 3-year project. And we're hoping to get to Sheffield, just outside the depot here. We needed one 400 kV grid connection. We changed 25 signal heads. We had 7 track interventions. Track loads, we're going through those later. We had 12 bridge interventions. And we introduced 5 new substations into the system. This is a huge piece of system engineering that was covered earlier in some of the slides. So Lucy.
Hiya, so I'm Lucy. I've been working for the last couple of years in the rail industry, and I went and did my degree at Loughborough University in materials engineering. At this point of my uni studies, I had no idea what industry I wanted to go into. But as part of my course, I had a year in industry placement and applied to the companies that were really recommended by my university. So I worked at Pirelli Tyres for a year in one of their rubber mixing factories as an efficiency assistant, which involved looking at the production data in the factory and working out where we could reduce lost time. So although I wasn't particularly a fan of the industry, I did enjoy the nature of the work. I went on to graduate in the middle of COVID, so I was looking around for jobs at that point and found a job opening in a company close to me, Valent, who produce boilers. They'd introduced a new robotic cell to construct boilers, and they needed some CE marking, UK CA marking now, to commission the cell. So I did that for a year and got a bit of experience in the sort of engineering assurance, which allowed me to apply for some roles at SPL Power Lines, where I work now as an assistant engineering manager. So when I started in railway, I didn't have any idea what was involved in railway electrification. I had the general idea that it was the overhead line equipment, the OLE, that powers the trains, but I didn't understand that there's so many interfacing disciplines to do with this. A few of the major ones here are the route clearance and track, which Simon will mention a bit later. You have to lift or move these often to get the OLE wires through. There's the substations Simon mentioned to power the rail, and some work in signalling, immunisation and signal sighting that I'll talk about a little bit. So in all these disciplines, there's also lots of different areas you can work in. Of course, there's the design teams, which do all the calculations needed to make the design of the OLE or the bridges. And then there's the construction teams that go out and physically put these on site. There's loads of areas you can work in. There's the environmental teams who do the surveys and ecological studies and look at reducing carbon in the projects. But I mainly work as part of the integration team, where we sort of look at all the interdisciplinary designs and do interdisciplinary checks to reduce clashes. So we work closely with the information management team because they hold what's called a federated model, which is essentially a big 3D model which shows what the railway looks like currently and then has all the 3D designs of the new infrastructure placed in. This is really useful for early clash detection to make sure you're not putting an OLE mast in a trough route or looking at potential risks like standing surfaces. So one area that I work in that we use this for is signal sighting. So the drivers require a certain amount of time to see the signal to safely act on these. We've run through the 3D model to check that the new OLE designs or bridge moves don't impact the sighting of these signals. So it will be still safe to run when it's commissioned. This saves a lot of money because these design changes can be made early on in the process, and it reduces the number of people we need on site to do these checks at the end. One other aspect that I want to talk about is the engineering assurance. So Simon mentioned we recently commissioned the Kettering to Wigston stretch of the Midland Main Line. In order to do this, we require a lot of engineering assurance, what we call Form E's and Form 5s, which show that the construction has taken place in accordance with the design, or if there's been any changes that have been made. This also shows that the required quality checks have been done and all the testing has been done to make sure it's safe. So for this project and this stretch line, there was over 400 pieces of documentation. So it's a bit dry and a bit hard work, but by the end of the project, it's really important because you can't commission without this. I think I'm going to hand you over to Simon now to talk about the more interesting aspects.
Thank you, Lucy. I'll leave it on this slide, actually. I think the attached slide is a real representation of the system, that whilst we have got individual discipline specialisms, mine is overhead line, everything's interlinked. The drainage is associated to the track's associated to the overhead line. The overhead line is associated to the E&P, the power, and the distribution system. So everything is linked to each other. So having a system approach is vital for the success of any major project. The next couple of slides, I'm going to go through on some work that Southampton University did with the Technical Authority on voltage control clearances. Electrification costs a lot of money, and we've got no money. Steve earlier spoke about decarbonising our network. We've got about 10,000 kilometres worth of electrification to do to electrify the rest of our network. So what do we do to reduce those costs? 30% of cost is embedded in civil engineering work. So we're working on a Victorian infrastructure. So our metric in a railway speak is an STK, single track kilometre, and that varies between £2 and £5 million per STK. So it costs between £2 and £5 million to actually put wires on our infrastructure, and it all depends on the complexity and where you are in the infrastructure. So Sheffield, for example, high complexity, high cost. So what can we do differently? We simply can't get the overhead line through the bridges, and that's a problem. We can't just not have overhead line there, particularly if we've invested heavily in rolling stock that works off 25,000 volts. We could increase the height of a bridge. That's quite costly. We could lower the track. That then interfaces into Mark's area of drainage. Interfaces in track. You lower the track, you're creating a low spot. You've got to deal with the drainage. Drainage becomes a real poignant issue around track schemes. Again, costly, very disruptive to the passenger. So what can we do? So Southampton University did some work to support the technical authority to look at reducing bending physics. How do we squeeze the gap between the pantograph, the 25,000 volts, and the top of the bridge? And that's where voltage control clearance comes from. The next couple of slides will go through some of the interventions that we use. We're using surge arresters. We're using insulative coating and contact wire covered. So we're fundamentally reducing the gap, the electrical gap between the earth and the 25 kV, allowing less bridge interventions, which basically means more electrification. This is an example middle and main line where we've applied this process. So this is very theoretical. It's then gone into a code of practice, into network rail, and we've now fully implemented this on a number of different bridges on the middle and main line. It's cost less. People are happy. People being the public. If you shut a bridge, knock a bridge down, it annoys people. You've also got significant issues over consents, environmental. How does that bridge operate in the local area? You're cutting off threads to bring communities together. So doing an intervention without having to do a physical intervention to the bridge or the track is always good. The next slide. This is a specification that was given to me about 6 or 7 years ago, and I was having a beer, and I was just starting London to Corby, and the biggest part of electrification, the biggest highest risk part of electrification is getting the foundations in the ground. What can we do to normalise that and repeat and apply a lean management technique to get as many foundations of the same type into the ground as quickly as possible? We've put in about 3,500 overhead line foundations on middle and main line so far. That's over roughly about 300 single track kilometres. That's quite a lot of foundations, a lot of tubular piles. And that picture there is actually taken by me somewhere near Grimsby, I think. And all these piles here are now in the ground, fully installed. Hopefully you can see the video. This is our preferred method. I'm not too sure if you've seen something like this before. This is a 610 tubular pile, like a pipe, that's vibrated into the ground until it reaches a natural refusal. At the top of the pile there are connections where you land the overhead line mast. So this is all part and parcel of the design requirements that we're also doing. When it hits refusal, this is the noisy bit. A hammer comes up and smashes it home. So for context, it's about £3,000 to put one of those in. The next couple of slides are going to go through on some alternative methods we've got where we use CHS technique, but using different techniques to go through difficult, challenging geology. But for context, for 1 metre concrete auger, which is a foundation, wet works, it's about 15 grand. So the differential is stark. So we want more of the same. We want more of the top. We want more of the 610s. We don't want the bottom one because that puts up costs and it puts up time. So part of my original specification about understanding and wanting or requiring a single foundation approach, we had to investigate whether or not something was feasible. So we looked at, I think, 1,000, if not 1,500 examples of structural loading northwest electrification and determined where the structural limits would be, the maximum, the minimum and mean. We then determined actually, I think 20 or 30% of the structured loading that we're likely to get will be outside the maximum permissible zone of a standard 610 pile. So we then had to think, well, how do we do that? What do we do to design that out? How do we use the 610 and design out the issue around the connection? So we designed a cap, a secondary pile cap in essence, where we removed the connection and create a cap that sat on top of a 610 CHS. as you can see, and that increased the foundation threshold by about 30% in terms of loading criteria, which meant I can install more 610 foundations in more places. But it came up with its problems, right? We were doing this at the same time as design, at the same time as construction. The top is an example of the pile cap with an overhead line structure on top of it. The bottom is actually an example of the pile cap sitting on a 610 with a snug fit. And the teams there are trying to squeeze it on. So we were developing and innovating at the same time as construction, always difficult, and we always come up with problems with research and development. But the pain was worth it. We had a 50% reduction in our foundation program, and we managed to go from about 60% of CHS to about 93%, which was industry leading at the time, and now everybody's following suit. What it meant was we were doing the same thing, repeating night after night after night, doing the same thing night after night after night. We spoke earlier about the down the hole hammer. This is a technique that Vanel have recently completed, where we've got stiff rock, underlying rock, where we can't use the MOVAC and we get refusal. So when the hammer hits a CHS home and it refuses, what do you do? So in areas where we identify shallow rock, we use a percussion technique. Hopefully these will work, and it just drills out the rock. It leaves a void. The void is then backfilled with gravel. Again, this used to be backfilled with wet works, with concrete, but we did some research and development, and we're now backfilling the void with gravel. You can see in the middle picture, you can see a 610 being vibrated in. If you can see the top of the pile there, it's got holes in it, and that will fit one of my pile caps. It's a very effective, quick and easy technique, but again, expensive, but significantly cheaper than sticking in a one-off concrete pile. So, in conclusion, the original pile had about 181 kilonewton meter overturning moment, equivalent of 5 elephants. We moved that to about 230 kilonewton meters, or 221 to be precise, which is about the equivalent of 7 elephants. So increasing the capacity, our loading capacity on our foundations by about 30% by introducing a secondary pile cap, which yielded a huge efficiency in the project and was one of the first projects that was built on time, on budget, particularly through COVID. So we're trying to take this on to the next level, a next level of innovation, which is quite difficult, but there's always things that we can do, and we need people like yourselves to come in with fresh ideas to think about how can we do this better, do this with more sustainable materials as well. That's it. Thank you. Didn't like the path. Okay.
Thank you. So any questions in the room for Simon or Lucy, or Simon and Lucy? I'm sure you find that very interesting indeed. Or any questions on Slido, please, Stephen?
The point is, what are the goals for next year?
What are the goals for next year?
Yeah.
Not too sure we understand that question. I don't know if the person who asked that in Southampton could be a bit more specific.
Does the revised design complicate maintenance?
Well, that's a fair question.
It is a fair question.
You have to stand, please.
Yeah, that's a fair question. It's interesting because it depends in what context. The pile cap, yes, for sure, but it's no different to the existing connections that are mechanical connections anyway. If we are applying BCC measures and we're saving in capex, we absolutely give opex a bit of a headache. So if we track lowering, it does affect interfacing disciplines that will cause opex costs, opex being maintenance costs, to go up. So things like drainage and additional maintenance regimes are needed of the consequence of the reduction in capital. So electrification projects and enhancements are always pushing and pulling against life-saving costs that will ideally, when we're in a position where we're increasing a route clearance or we're knocking down a bridge, that's the right thing to do. But we simply haven't got the money to spend, because it costs between, I don't know, £3 to £4 million to knock a bridge down. It might cost £1 million to do a track lower. The project's always pushing and pulling against our maintenance colleague versus what money's left actually to do the physical works itself.
Yeah.
It is.
It's
Yeah.
Simon's dream world. What would it be?
Well, yeah.
Infinite.
Yeah, I think there's 10,000 kilometres that are needed to fulfil decarbonisation if you factor in things like fully electric trains, but now they've got tri-trains, bi-mode trains. So bi-mode trains have been introduced on middle and main lines. You've got they're diesel electric. So you operate diesel when there's no overhead line there. When there is overhead line there, the pantographs are raised and it pulls 25,000 volts to power the train. So we're getting around areas where electrification could be overly complex. Sheffield could be an example of that. But some electrification is better than no electrification. I think the pipeline is limited at the moment. But there's a 2050 that we're all heading toward 2050 for full decarbonisation. So we need to do something.
Yeah, and it's all about doing things efficiently, because obviously we all know the government haven't got a lot of money, and where they do have their money, they've now dedicated a lot to the health service. Yes, they put some in transport, but for people working in this industry, we have to be able to show that we can spend that money very efficiently and effectively to gain their confidence to be allowed to deliver more projects. So, which is why you need all young people like you with great ideas of how you could do things differently.
Agreed.
Yep, for sure.
Could I just ask what the next phase of electrification on the middle and main line will be and when it is? You've reached Wigston, south of Leicester Junction, I think. Are you going to be electrifying north to Leicester and Derby, or I don't know about the funding in CP7?
Good question again. So currently we, as in SPL or Network Rail, have given a contract to SPL to design at AIP, which is proven principle. The overhead line from pretty much south of Wigston, so that's Leicester Station, through to Nottingham and through to Derby and a bit north of there. Currently we're negotiating Sheffield, an area of high complexity, but that's it. And that's all the funding. That's all the funding is there. So that's maybe £20 million worth of funding, but maybe £900 million of requirements to deliver the scheme. So if somebody can find £1 billion, then they know where to come.
Okay, right.
Good question.
Okay, so I'm going to say thank you very much to Simon and Lucy.
Yeah,
thank you.
thank you.
Thank you. Right. So now, team down in Southampton, we're going to say goodbye to you because you've got Diana there. So thank you very much for joining us this afternoon. I hope you found the presentations useful. Please don't forget to do the ballast competition if you haven't done it already, because there's £100 up for grabs if you can guess the nearest correct number to the pieces of ballast in your container there. I've seen a photograph of it in Southampton. It looks very glamorous indeed. But we're going to leave you now. Okay, so thanks very much for joining us. Thank you. And now we've got one more presentation here